Hello dear students, welcome back to my class. This is my second lecture. Okay, so now today I will going to revise what we have discussed in the previous class. So we got the two main domain of interest in physics. One is macro, another one is micro. So we have been discussing about the macroscopic domain, right? In macroscopic domain, they includes the subjects like mechanics, which is static as well as dynamic, and electrodynamics, optics, and this is thermodynamics. Okay, as I told you, so in mechanics we are going to discuss the body at rest as well as the motion of a body and propulsion of the rocket, recoil of gun, right? So many things. And in electrodynamics we specially deal with the phenomena of electrical field or magnetic field, right? Or electric field, magnetic field. And in optics, a branch of science or branch of physics specifically which deals with the light. Okay, so in here in optics we have lots of interest, means lots of topic like construction of microscope, construction of say telescope, as well as the color exhibited by the thin films. So this optics will get in class 12, okay, not in the class 11. Okay, so now when I say optics, there are two types of optics. How many types? Two types. We are going to get in class 12. One is ray optics, another one is wave optics. So in ray optics, we will assume the light as a light travels in a straight line, means one point into another. But in case of wave optics, we'll consider the light has a wave nature, like up and down wave, right? Compression and rarefaction. Okay. So now, but we have to remember that light is what? Light is a transverse wave. Up and down, it oscillates like this. Okay, it's always perpendicular to the direction of the propagation of light. Okay, so the last topic that we have discussed in the lecture 1 was like thermodynamics. Okay, so thermodynamics deals with the system, means large system which is in the macroscopic equilibrium. Okay, so let me understand, or let me explain in the simpler way. Okay, when I say thermo, this is heat. Thermo means what? Heat. When I say dynamics, this is what? In simple sense, I can say this is flow. Okay. When I discuss about the flow of heat, this is called thermodynamics. Okay. So thermodynamics, this is a very interesting part, because once we know the thermodynamics, we know how to design cars, how to design the car engines, how to design the heat engine, how to design the refrigerator, how to design so many, right? So many machines, how to design, means like there are numerous ways. Okay, so when we learn the thermodynamics, okay, so now, so this is about the scope of physics. So now we have finished this macroscopic. Now I'm going to discuss what is the microscopic domain of physics. Okay. Okay, so in microscopic domain. Okay, so dear students, when I say macroscopic domain, here we deal whole macroscopic domain with the help of the classical physics. Okay, but when I say micro, sometimes we feel like classical physics falls short, or there is we feel this is inadequate to discuss the microscopic domain. So we have special kind of physics to deal with the microscopic domain. There is quantum physics. So quantum physics has accepted as a proper framework to deal with the microscopic domain. So as the name suggests, micro, right? Micro, it is opposite to macro. Micro means small, right? Very small. Like in microscopic domain, we are going to discuss the atomic particles and subatomic particles, what inside the atom, electron, protons, neutrons, right, what inside the nucleus. So it's going to deal with what? Subatomic or atomic particles. Okay, it's a very small object, I can say particle, which cannot be observed or visualized, which cannot be visualized by our naked eyes, right? So these are very small things. Okay, so we deal with this field of science with the quantum physics. Okay, quantum physics. Okay, so this is about the microscopic domain. So I think now you are very clear what is macro and what is micro. Okay, now so let's discuss the excitement of physics. Okay, so excitement of physics. excitement of physics. So now, dear students, so why physics is so exciting? Okay, why physics is so exciting? Why this is so interesting? I myself found physics is very interesting. Okay, that's why I have chosen the physics. Okay, now you say, what is the excitement? I'll tell you some few examples, maybe 2, 3. Okay, first, when you pursue the physics, so in physics, every day we'll get to learn the new things in the laboratory. So we can learn new things, or in the language of science, I'll say this, new experiment. We can learn new experiment, new experiment in laboratory. We can learn new experiment in the laboratory on the daily basis. Means every day we are going to learn the new things in our physics labs. And next, when you learn the physics, when you know the physics, right, when you can understand the physics, we can discover the secrets of nature. We can discover what? Secrets of nature. Means what is the logic behind the natural phenomena. And once you can know the secrets of nature, then you can obviously control that natural phenomena, right? Once you know the secrets of nature, then you can easily modify, you can easily control that nature, or control that natural phenomena. And next, the third, the law of physics. When we learn the law of physics, we can use the law of physics to solve our day-to-day life problems. Okay, so we can apply the law of physics. We can apply the law of physics to solve the day-to-day life, means daily life problems. So for example, suppose electromagnetic induction, that you have already learned in class 10, right? By using the principle, this is the basic law of physics, what we call electromagnetic induction. By using this electromagnetic induction principle, we can design fan. We can design what? Electric fan. We can design refrigerator, right? We can design what? Refrigerator. And from the refrigerator to the electric train, okay, we can govern each and every vehicles or each and every machines with the help of electromagnetic induction. So this is very interesting. Once you know the law of physics, you can invent the things, you can design, you can understand the machine, how it works. You can build, if you know very deep, if you know in depth, right? You can design your own machine, you can design a car. When you become, say suppose, when you become a mechanical engineer, right? You can design a car, right? So there are so many things. So this is the excitement about the physics, okay? When you, in physics, we can measure very small objects, like suppose there's potato, 1 kg of potato, 2 kg of rice, right? Everything, everybody can measure. But here in physics lab, we are going to, we can measure what is the radius of an atom, right? Which we cannot see by our naked eyes, right? What is the weight of the small atomic particle? What is the weight, right? Everything we can measure with the, we have different instruments for that. Okay, suppose the formation of rainbow, how the prism works, everything we are going to learn in the physics laboratory. So it's going to be very interesting, right? So this is about the excitement of physics, and you can find out when you go through the book, you'll get lots of excitement things about the physics. So next, okay, so in physics there are two main principles of trust. Okay, so two main principle of trust. Okay, so in physics there are two main principles of trust. Okay, so number one we call this unification, and number two approach, or number two principle is reduction. So first let me tell you what is unification. In physics what we try to do, our attempt, we always try to explain, okay, so many things with a few things. Okay, it means like we try to explain the so many different phenomena in terms of few laws as well as the few concepts. Okay, let me give you one example for that. Suppose if I say your part 1 physics, as I told you, the mechanics. In mechanics we'll get lots of different things, motion of car, motion of a body, means any kind of non-living things, and motion of an animal, right? Animal, so many things. Okay, we can govern by a few laws. Okay, so any motion can be expressed, or any motion can be explained by the 3 equation that given by Newton. What equation was that? That is S equal to ut plus half at square, and one is v equal to u plus at, and one is v square equal to u square plus twice as. Now you just think this, by using these 3 equations of motion, we can understand the motion of a plane, right? Motion of a plane, and as well as, I mean plane means aeroplane, and motion of a body when you throw something. This is what we call projectile, and we can understand by these 3 equation of motion, which is given by Newton's, which is given by Sir Isaac Newton. So what is unification? Unification is a concept, is an approach of physics where we try to deal, right? Where we try to deal the diverse physical system in terms of few laws as well as few concepts. As I tell you, the Newton's law of motion, we can describe the falling of an apple to the ground, right? With the help of Newton's law, we can describe the falling of an apple to the ground, as well as with the same law we can define, or we can explain the motion of earth around the sun, as well as the motion of the moon around the sun. So the things is very interesting, right? What is Newton equation? As you know, this is F equal to ma, right? But now you think once, by using this F equal to ma, or by the law of gravitation F equal to capital G m1 m2 by r square, we can explain the motion of the earth around the sun and motion of all the planets around the sun, right? The whole solar system. And you can define, or you can explain the galaxy, you can define the stars, their motions, right? That's very interesting. This is the concept of unification. Few concepts, but so many phenomena we can explain. Okay, so next thrust, or next principal approach in physics is what we call reduction. So when I say reduction, how does it work when I say reduction? So reduction, when suppose I want to learn the properties of behavior of a very large or very complex system. Okay, so how we learn in physics? Okay, what we do, suppose you have some body which is very big, very large, okay, bigger than your size, okay, but I want to know the property of that body. So what I'll do, I'll take out some few particles from that body, okay, and I'll study the atoms. And once I know the properties of the atoms, I can easily tell what is the properties of that large systems or that large body. This is what we call the process or the approach reduction. Okay, so this is about the 2 principal thrusts. Okay, now we'll discuss the different thing. We'll switch to the other topic. So that is say physics and technology. That is physics and technology. Physics and technology. So when I say physics and technology, right? So first tell me what is science and what is technology, right? I hope you guys know it, right? So what is science? Science is nothing but the laws that we study, right? The Newton's law, Coulomb's law, and Faraday's law, Ohm's law, all these laws that we study. These are the law. These are the statements given by the scientist. And when we use all those laws to build some new things, or when we use when we use this law to build some machines, build some systems, this is what we call technology, right? Technology is what you can see, the car, right? Any vehicles, right? Spacecraft, everything is technology. But when we say science, this is the law of science. That is Newton's law, F equal to ma. Suppose F equal to G m1 m2 by r square. So suppose Coulomb's law, F equal to k q1 q2 by r square, right? All these are laws. All these are science. This is what? Science. Okay, means this is what, when we say in particular term, say this is physics, when this is the laws related to physics, that this is physics law. And technology is what? When we design something by using the law of physics, that is what we call technology. So in terms of physics and technology, okay, in some cases we got the technology first, and then we develop physics. And in some cases we have already the laws of physics, and by using the law of physics we have designed the technology. So let me give you one example. First, if I discuss about the heat engine, if I discuss about what? Heat engine. First, the people invented heat engine. Okay, some scientist, he invented heat engine, and after that the particular group of people, right, particular group of people, they try to understand how does it work, how it works. So what is the principle behind that, and they try to understand the whole heat engine, which leads to the entire branch of the physics, which is called, as I already mentioned, which is called thermodynamics. Okay, which is leads to the new branch of physics, what we call thermodynamics. Okay, so the thermodynamics part is very interesting, but suppose luck by chance, when you become an engineer, when you go to engineering college, right, here when you become a mechanical engineer, you are going to study the thermodynamics. It's going to be very interesting, because when you go for mechanical engineering, right, the things are what, based on, you know, based on building means designing that machines, designing the car engines, and designing the different kind of, you know, different kind of engines of the machines, right. So here you are going to discuss mostly on like that thing, thermodynamics. Okay, so now, so as I told you, sometimes technology comes first, and after that this is physics, which gives rise to the physics. So from heat engine we got the thermodynamics. Okay, in most of the cases physics comes first and then technology. For example, if I say, suppose semiconductors, right, semiconductors. Okay, when I say semiconductors, okay, the semiconductors which give rise to the computer revolution, right. So every computer chips, okay, computer chips means whether you are using the memory card, whether you are using you know, the integrated circuit inside the computer, inside your mobile phone, right, so many electric gadgets, so many gadgets, okay, everything based on the semiconductors. So first there is a laws and there is a study in physics where we are discussing about the semiconductors, but when we try to use the semiconductor in practical purpose, it leads us to design computers, design mobile phones, and lots of things, right? Because semiconductors, when we say semiconductor, it is nothing but it is a combination. It's like it is the combination of resistance, it is the combination of a transistor, it is the combination of capacitors, all these kinds of things. Okay, all these kinds of things. Okay, so this is how we can say physics and technology are closely related. In some cases technology is first, and in some cases physics is first. Technology gives rise to the physics, and sometimes physics gives rise to the new technology. Is it clear? Okay, because in physics we try to discuss the lever system, right? Lever system, say lever system. Okay, that lever system helps us to design the entire machines. Okay, and when the study of satellites, right? Study of satellites, okay, which help us to forecast the weather very accurately, right? This is the branch of physics where we study the satellites, which gives us, which helps us, sorry, which help us to understand, or which helps us to give the exact report of the weather. Okay, and let me give you one more example, right? Nuclear fission. When I say nuclear fission. So nuclear fission. So once we have studied, or once we have discovered a phenomenon behind the nuclear fission, okay, this is proved to be the tremendous source of energy, right? When we, I think you guys already know that nuclear bomb, right? How powerful it is, nuclear bomb, nuclear reactor, how powerful it is, right? This is nothing but the physics behind it. Nuclear bomb or nuclear, you know, the nuclear reactor, this is nothing but the nuclear fission. What is the principle behind it? We can convert mass into energy, right? Mass into what? Energy. Once we knew that we can convert mass into energy, we can build a very large or tremendous source of energy, right? Nuclear reactor as well as a nuclear bomb. Okay, so there are lots of examples, right, which helps us to understand the relation between the physics as well as the technology. Okay, so we're running out of time, dear students. So this is about the second class, and we'll discuss more details in our next class. Thank you.